Hi students, today we shall discuss chapter 3, lines and angles. Okay, so about lines and angles we have learned in the previous class also. So now we will recall them, basic terms and definitions. So we will study line, segment and ray, so also non-collinear points and different definitions. Okay, collinear points and all. So first of all, line segment, I have given the definition in the previous class, in previous chapter. Okay, line segment is nothing but a part of the line with two endpoints. Okay, so similarly a ray means a part of a line with only one endpoint. Okay, that is called a ray. If you consider a straight line, then in both the direction we can extend. Okay, so if you consider any 2 points, then this portion AB, this portion of line is called line segment. So if you consider only one point and this portion is called in this direction no end, so only one end point, then it is called a ray. Okay, so ray looks like this. This is ray. So line segment looks like this, line segment. Okay, so this is about line segment. Then we have 3 points, that is collinear points. If 3 or more points lie on the same line, they are called collinear points. Okay, so whenever you consider 3 points, so they may lie anywhere, correct? So if you can join all these 3 points using same line, then those points are called collinear points, definitely. So these 2 points can be joined using a straight line, but we cannot join using the same line. So therefore, so if you consider, if you can draw a line which passes, straight line which passes through all the 3 points, then these 3 points are called collinear points. Okay, so if the 3 points lie on the same line, then those points are called collinear. Okay, otherwise they are non-collinear points. So non-collinear means we cannot join all the 3 points using same line, right? So that is about non-collinear points. And we will learn about angle, vertex and arms. So whenever you consider angle, so 0 degree to 90 degree, so that angle is called acute angle. So in the angle, so there is a vertex, this point of intersection of two arms, two lines is called vertex, and these two lines are called arms of an angle, and this here you will write the value. Okay, so angle value we will write here. So if the angle value is 0 to 90 degree, then it is called acute angle, in between 0 and 90. If it is 90, then we call it as right angle, okay, 90 degree. And if the value is more than 90, less than 180, then it is called obtuse angle. Then it is a straight angle, 180. If the angle value is 180 degree, then it is straight angle. So if it is more than 180, less than 360, then it is called reflex angle. More than 180 means 200, 210, those angles are called reflex angles. So then we have adjacent angles. So adjacent angle means, so there will be 3 arms and one arm will be common to both the angles, and there will be a common point, common vertex for all the 3 arms. So in that case, these 2 angles are called adjacent angles. Okay, so they will be having common arm, and these 2 are called non-common arms. Okay, so that those angles are called adjacent angles. So here linear pair angles. So if whenever you consider a straight line and a line standing on this line, then these 2 angles are known as linear pair angles. So linear means line. Okay, so considering a line and one more line, so then these 2 angles are called linear pair of angles. Okay, so these are also adjacent angles. Okay, because this is a common vertical, common arm, you can say. So these are also adjacent angles, but since it is a straight line, we call it as linear pair of angles. You can also call them as adjacent angles, no problem. Then comes vertically opposite angles. Whenever 2 lines intersect, so these 2 angles will be equal always. Okay, so these 2 angles are called vertically opposite angle, and also these 2 angles are called vertically opposite angles. I hope you know how to write angles. So if you consider this angle, that is double bar, so it is written as angle ABD or angle DPA. Okay, like this you can write angle ABD. Also you can write angle DBA. So this point where the angle is denoted must be in the center. Okay, so B in the center. So similarly here also angle ABD is this angle, angle DBC is this angle. Okay. Okay, then comes intersecting lines and non-intersecting lines. So when two lines intersect at a point, then those two lines are called intersecting lines. So intersect, that's all. They meet at a particular point. If they do not meet when we extend in the both direction, so they are called parallel lines or non-intersecting lines. Okay, so these are parallel lines or non-intersecting lines. Then we have Axiom 3.1, that is, if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. So that is, if you consider a line here like this, straight line, and if one more line stands on this line, then these two angles will be adjacent angles. Okay, these two angles are called adjacent angles. If you add the value of these two angles, then it will be equal to 180 degree. So for example, if this is 60 degree and this is 120 degree, 60 plus 120, 180 degree. So whenever you consider straight line and a line here stands on that same line, then sum of these two angles is always equal to 180 degree. Okay, so that is linear pair of angles. These angles are called linear pair of angles. Then we have Axiom 3.2, that is, if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. Okay, that is, whenever you consider two adjacent angles, if the sum of two adjacent angles is 180 degree, when you add the value of x and y, these two values, if that is 180 degree, then non-common arms. So when you consider adjacent angles, so this is called common arm. These two are called non-common arms. Two non-common arms form a line. Okay, you can see here, form a line. So that means this will be a straight line. These two together form a straight line if the sum of these two angles is equal to 180 degree. So converse of 3.1 we can say. So this is 3.2. Okay, now we shall discuss theorem 3.1. So that is, if two lines intersect each other, then the vertically opposite angles are equal. If I consider two straight lines like this, two straight intersecting, if two lines intersect each other at this point, so let me consider this point as A and this as B, C, D, and let this point be O. Okay, O. Now when two lines intersect, vertically opposite angle, these two angles are called vertically opposite angles, and these two angles are called vertically opposite angles. We have to prove that these two angles are equal and also these two angles are equal. Okay, so to prove angle AOC is equal to angle BOD, that is AOC this angle and BOD this angle. We have to prove these two angles equal, and COB, angle COB is equal to angle AOD. Okay, two angles. Proof. Okay, so we have written here proof, no need to write. Okay, so now from the figure what we can say, AB is a straight line, so therefore I can consider linear pair angles, these two angles, adjacent angles, and also linear pair angles. So that means angle AOC plus angle BOC or COB, angle AOC and angle COB, these two angles is equal to 180 degree because linear pair angles. Okay, because linear pair of angles, linear pair of angles will be equal to 180 degree. Okay, so also Also angle COB plus angle BOD is equal to 180 degree, because CD is a straight line, so these two angles will be equal to 180 degree, linear pair of angles, these two angles. Okay, so that is equal to 180. So same reason, because linear pair of angles. So we will consider it as equation 1, equation 2 from 1 and 2, so 180 equal to 180, so therefore I can equate these two equations, okay, expressions. Angle AOC plus angle COB is equal to 180, that is equal to this angle COB plus angle BOD, right? Since right hand side equal, I can equate left hand side, those will be equal. So therefore angle AOC, angle COB I can cancel, okay. So they have same sign, but they are on the either side of equality sign, okay. So therefore angle AOC remaining is equal to angle BOD remaining. So that is the first proof, okay. So this is the proof. So this is how we prove. So in the same way second one, okay, to prove second result, I will consider CD, straight line first. So that is, we have to prove these two angles equal. So angle COP is equal to angle BOD, plus angle COB plus angle BOD is equal to 180 degree, okay. Equation 3. What is the reason? Linear pair of angles. And next I will consider AB, so this line, so that means angle BOD plus angle AOD. So these two angles, adjacent angle, linear pair of angles, sum is equal to 180 degree. So this is fourth equation, same reason, because linear pair of angles. So therefore from 3 and 4, right hand side equal, 180, that means left hand side must be equal. So angle COB plus angle BOD is equal to angle BOD plus angle AOD, okay. I can cancel BOD, angle remaining COB plus is equal to angle AOD, and that is the required answer, okay. So an important theorem. Okay, we shall discuss next problem, and that is exercise 3.1. So in that first one, in the figure 3.13, lines AB and CD intersect at O, okay. So a figure is given here. If angle AOC plus angle BOE is equal to 70 degree and angle BOD is equal to 40 degree, find angle BOE and reflex angle COE, okay. This is the given question. Angle BOD is equal to 40, that is BOD is 40 degree, we will write here. So and angle AOC plus BOE, AOC this angle plus BOE is equal to 70, sum of these two is equal to 70, so we cannot write 35 like that, okay. We don't know, so it may be 40 30 25 60 55 like that, okay. So we have to find BOE, so this we have to find, and reflex of COE. So reflex of COE means this angle, okay, reflex. So we will start solution. Angle BOD is equal to angle AOC. Angle BOD is equal to angle AOC, because CD and AB are straight line intersecting at this point. These two angles will be vertically opposite angle. So therefore, if this is 40, this must be 40. Okay, vertically opposite angles are always equal. So therefore, AOC must be equal to 40 degree. So this is 40. So now using this equation, we will find this one. So that is angle AOC. Okay, you can write here reason, because vertically opposite angles, and now AOC plus BOE is equal to 70 degree, and AOC, we have found AOC, that is 40 degree plus angle BOE is equal to 70 degree. So therefore angle BOE is equal to 70 degree. This plus 40 becomes minus 40. No sign means plus, okay, so it becomes minus. So that is equal to 70 minus 40, 30 degree. Angle BOE is equal to 30 degree. So that was the question. Find BOE. Then reflex COE. So we have to find, so this angle. So before finding that, we will find this one. We will find this angle, and complete rotation means 360. So from 360 we will minus this portion. So then we are going to get this one. Okay, we will find this using sum of the linear pair angles. Okay, so whenever we have straight lines, sum of all the angles, it may be 2 or 3. If we consider on the same side of a line, then sum will be equal to 180 degree. Okay, so that concept we will consider. From the figure, angle AOC plus angle COE plus angle BOE is equal to 180 degree. Linear angles, you can write linear angles. So there is one more method also, you can use that method also to find, but you can use this one also. So all the three angles. Now we know that angle AOC plus BOE, instead of angle AOC plus BOE, I can write 70 degree for these two. Okay, plus angle COE, I will keep as it is equal to 180 degree, and therefore angle COE is equal to 180 minus 70, that is angle COE is equal to 110 degree. Therefore reflex angle COE is equal to 360 minus 110, that is equal to, I think, 250. Reflex the vector. So this is how we find reflex angle. Okay. Second problem, in the figure 3.14, this figure, lines XY and MN intersect at O. Lines XY and MN intersect at O. If angle POY is equal to 90 degree and A is to B is equal to 2:3, A is to B is equal to 2:3, find C. Find C. Okay, so that is the question. Okay, this is the diagram. We have to find C. Okay, find C. A and B are in the ratio 2:3. Okay, and PO, this is O. Okay, point O, Y is equal to 90 degree. So before finding C, so we will find A and B. So to find A and B, we have to find POX, because POY is given. We can find POY using linear pair of angles, because POY and POX are linear pair of angles. Okay, solution, angle POY plus angle POX is equal to 180 degree, linear pair of angles, linear pair of angles. Okay, so POY is given, POY 90 degree plus angle POX is equal to 180 degree. Angle POX is equal to 180 minus 90. Okay, plus becomes minus. Angle POX is equal to 90 degree. So now POX is divided into two angles A and B. So therefore, so this is POX is equal to angle A plus angle B is equal to 90 degree. So this angle sum must be equal to 90. So now angle A is 2:3. So that means you have to consider it as 2x plus 3x. Whenever angles are given in the ratio 2:3, so in that case you have to consider it as 2x, 3x, 90 degree. So 2x plus 3x is 5x is equal to 90, and x is equal to 90 by 5. 5 ones are 5 ones are 5, 5 8s are. X is equal to 18 degree. Okay, so therefore angle A is equal to, angle A is 2x, that is equal to 2 into 18, that is equal to 36 degree, and angle B is equal to angle small b 3x that is equal to 3 into 18 is equal to 54 degree. Okay. Next we have to calculate, our aim is to calculate C. So, and here in the figure you can see that B and C are linear pair of angles. Okay. So therefore I can write angle B plus angle C is equal to 180 degree. Now angle B plus angle C is equal to 180 degree because linear pair of angles. Okay. So angle B we have found here 54 plus angle C 180 degree. Angle C is equal to 180 degree plus 54 becomes minus 54 degree. So that is equal to 180 minus 54, I think 126 degree. Angle C is equal to 126 degree.